As a pre-calc student, uh-oh. Battery is getting low. I'm going to switch mics. All right, hopefully this one works. So, as a pre-calculus student, this should make you a little bit frustrated. Like, that does not seem very accurate, Mr. JR. A little bit less than 60. Pre-calculus is supposed to be about precision and knowing exactly what something is. So to say that 1 radian, okay, the definition is fine, but to say that that angle is a little less than 60 doesn't make it feel very accurate, okay? But we can use the circumference to figure out what this is exactly. First of all, you already know the circumference formula. But I don't know if you've ever really thought about what it means. Circumference formula is 2 pi r. It has r, which is a radius. Circumference measures a distance. It's the distance around a circle. If we calculated what is the distance around the circle in terms of radiuses, this would be 1 radius. This would be another one. I don't know, this is another one, then another one, then another one, then another one, and then maybe a little bit more. If we measured how many radiuses fit around the circle, actually maybe cut them out with string and glued them to the edge of the circle, we would find that there are 6 and a bit radiuses in a circle. Our circumference formula, though, tells us, right, 2 pi is approximately 6.28 dot, 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 6.28 radiuses. Now, if the definition of 1 radian as an angle of measurement is equal to the angle when the radius is the same, and we know how many degrees are in a circle. 360. You know that there's 360 degrees in a circle. How many radiuses are there in a circle? Well, from your circumference formula, there are 2 pi radiuses in a circle. So we can now say we have this definition, that 360 degrees is the same as 2 pi radians. If you wanted to figure out what 1 radian was, how could you do that? You would have to divide this side by 2 pi. So you'd have to divide this side by 2 pi. If we go to our calculator and test that out, 360 divided by, wait for it, 2 pi. Put the 2 pi in brackets because you're dividing by more than one thing. Push enter, 57.295. That's more accurate. So 1 radian, I'll put it as approximately here. Wow, that is quite the approximate sign. A little bit less than 60 degrees ends up being exactly or approximately 57.3 degrees. By pushing that equilateral triangle down to make this perfectly along the edge of a circle, that angle changed by almost 3 degrees. So we're going to start talking in radians instead of degrees for a lot of this unit. One of the reasons mathematicians like radians is Circumference doesn't change no matter how big or how small an angle is, or a circle is. Radians are actually connected to a circle. They mean something. It's when the radius is equal to the arc length, whereas degrees is arbitrary. Who decided 360? Like, why 360 degrees in a circle? No, just like, I don't know either. Maybe because it was close to, like, anytime we do things in circles, we think about things that repeat each other. The year, how many days are there in a year? 365, right? But that would have messed up our math, right, a little bit if we used 365 because it doesn't divide nicely. You wouldn't have 90-degree angles. You know, your calculator has another one called gradients. Do you know how many gradients around a circle? 400. So that instead of a 90-degree angle, it's a 100-degree angle. Wouldn't that mess you up now? But it's also arbitrary. Okay? Radians is the only one that isn't arbitrary. It's based on an actual measurement. But basing it on an actual measurement causes some problems because instead of a nice whole number like 360, you now have 2 pi. And I think about trying to teach kids in grade 5. Yeah, okay. Jump up in the air and do a 2 pi, right? Right? It just doesn't sound as good. Like I'm watching, I would love, oh, this would be a good project. Take a snowboard Olympics or X Games one where they're doing commentary, where they're talking about, you know, doing a 1080, is, you know, the spins that are in the air. They're always talking about degrees, right? How many times in a row is a 1080? That would be turning once, twice, 3 times in the air, right? Change that all to radians. And would you be able to understand the commentary as much? Or would it be confusing? Okay? So we've got that this is one that should be the one that helps you remember that there are 2 pi radians around the whole circle, radiuses, I guess. And so that means there's 2 pi radians, and that's equal to 360 degrees. Yes. Can you see that if you divided those by 2, that you already know that halfway around the circle is 180 degrees? Halfway around the circle in radians would be pi radians. And on your next page, oh, I guess the other one that sometimes comes up, I'll write it down too, but it's on your next page as well. Does it make sense that if you wanted to find, I like to use this blue one to find 1 degree. If I wanted to find out what 1 degree was, I would just divide this side by 180, so I would divide this side by 180. And 1 degree would be pi over 180 radians. Similarly, you have 1 radian is 360 over 2 pi. You could reduce that to 1 radian is 180 over pi degrees. And you're going to have to switch back and forth so that when I say 30 degrees, you're like, oh, that's the same as pi over 6 radians, right? You're like, I know 30 degrees. Pi over 6 right now doesn't make sense to us, right? 45 degrees, that's pi over 4. Again, how do we switch back and forth? 45 degrees is pi over 4 radians, okay? Now, something that's going to get you confused in this unit, right? I mean, there's lots of things that can get you confused in this unit. But just a question for you. Is 1 equal to 12? No? How about if I say, is 1 foot equal to 12 inches? Yes, right? So they're equal if you put units on there. We're able to say that 180 degrees is equal to pi radians. But 180 does not equal pi. Pi is still and will always be 3.1415965, for a very long time, continuing. But 180 degrees is pi radians. But sometimes people will want to say that pi equals 180. And that's only true if you include the units. So we have this at the top of page 489. It has what 1 radian is, what 1 degree is. It has these important definitions of 360 degrees and pi radians. Right beside this, you have this space right here as well. We are now going to change our arc length formula, because remember when we did our arc length in degrees? We had the arc length was the angle out of 360, because that was the proportion times the circumference. And we use the letter S for arc length. We are now going to make our arc length formula in radians. It's still going to be S. We're still going to have theta on, but instead of 360 degrees, what would we write instead? Well, what's 360 degrees equal to? 2 pi radians. So we would put 2 pi down here. And then our circumference is 2 pi r. Now, as far as understanding formulas go, I would love to leave that formula like that. But this formula for mathematicians is just too tempting to simplify. Can you see if I make 2 pi over 1, and you multiplied those fractions, how many things would cancel out? Can you see that the 2's would cancel out, the pi's would cancel out? And because so many things cancel out so nicely on your formula sheet, you have the following formula. Theta r. Okay? Again, personally, I like this formula and this formula better because they have meaning. They are a proportion of the circumference. But I can totally understand when those 2 pi's cancel out so nicely that reducing it to theta r makes sense. Okay? This formula is on your formula sheet. This formula, though, only works in radians. If you know the angle in degrees, it won't help you. So that tells me if I have a circle, and if I pick an arc length of 3 radians, and the radius is 10, I know that this length is 30. Because 1 radian is 1 radius. So if this is 3, that would mean I'd have 1 radius of 10, then 2 radiuses of 10, then 3 radiuses of 10, and my arc length would be 30. The formula shows that, says arc length is equal to the angle in radians, and I said my angle was 3 radians, times my radius, which is 10, gives me 30. Question? What's that? Like if you wanted to figure out how long this was, well then you would have to know what this length is. And this length would be 2 pi minus 3 as an angle. Because the whole thing is 2 pi, just like the whole thing is 360. If there's 3 an angle of 3 on the top, there's 2 pi minus 3 on the bottom. And I mean, that's not too hard to estimate. If I wanted to figure out this arc length in green, as an estimate, can you see 2 pi is 6.28? Minus 3 would be 3.28. This green arc length would be approximately 3.28 times 10, because the radius is 10, which would be 32.8. So now we can do what makes grade 12 interesting for trigonometry is now that we've learned radians, we can go back and do every single trig question you've done in grade 10 and grade 11 and grade 12, and the only thing we do is change the question from being in degrees to radians. So for example, here's a triangle. This side is 5. This angle is pi over 6. How long is this side? What would you use? SOHCAHTOA, sine, cos, or tan, if you were figuring this out in grade 10. Right, you got opposite, you want to find hypotenuse. SOHCAHTOA, you'd use sine. Sine of the angle, pi over 6, equals 5 over, I'll put an x here, x. How did you solve this in grade 10? You'd multiply both sides by x, and then divide both sides by sine, and you get x equals 5 over sine pi over 6. But when you go to your calculator might be in degrees, right? And I can't use my calculators. Right now it's only working in degrees. So we will have to learn how to change our calculator from degrees to radians. Lots of times there's a mode button on your calculator. So when I hit the mode button on my calculator, right now degrees is highlighted. I can change it to radians. Okay? Then I go and type in 5 divided by sine of pi divided by 6. Here's some good mental math for you. You ready to do that in your head? Yeah, it's 10, right? Oh, good. Perfect. So we figured out this is 10. You could have done this same question if it was degrees. First of all, a quick way to switch this to degrees. Pi radians is how many degrees? 180 is pi radians. What's 180 divided by 6? I'll redraw this triangle in degrees. 30 degrees. This is 5. Change our calculator back to degrees. Hit the mode button. Back to degrees. Can you see that this question would have been the same as doing 5 divided by sine of 30? So I go to my calculator. I do 5 divided by sine of 30, and I get 10 as well. You get the same answer, but your calculator has to know what you're talking about because it needs to know what units you're using when you're talking in angles. So we're going to be redoing a lot of the math we've already done with trigonometry with new angles as radians. We're going to redo some of the trigonometry we've already done when we get to example 1. And we're going to be practicing switching from one to the other. So in part A, it says you have 170 degrees. Off to the side, I'm going to remind you that 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. Those are going to be very important because if you're switching from radians to degrees, you're going to multiply by 180 over pi. If you're switching from degrees to radians, you're going to multiply by pi over 180. This is going to be problematic for you because are these similar? Yes. Can you see yourself mixing them up? Yes. So how do we make sure that we don't mix them up? So I want to change 170 degrees to radians. I'm going to include my units there. My question is, should I multiply by this one or should I multiply by this one? I'm going to multiply by the bottom one, and if you write it as this, can you see that what I'm multiplying by is equal to 1? In other words, what's 12 inches divided by 1 foot? They're the same measurement. It's equal to 1, right? If you take the same number, 7 divided by 7 is 1. A kilometer divided by 1,000 meters is 1 because they're the same thing, just in different measurements. And do you know when you divide, things cancel out? So think here, you want your degrees to cancel out. And we're left with now, nice thing about grade 12 pre-calculus. You do not have to simplify fractions if you don't want to. You could simplify this. Can you see this is the same as 17 pi over 18? Okay? You could simplify it. Your answer key in the back of your textbook probably has it simplified. But on a test, if you leave it as 170 pi over 180, that's perfectly fine. We call this answer, this one, or this one, an exact answer because it leaves it in terms of pi. If we type that into our calculator, 2.967 to the nearest hundredth, you get 2.97. We would say this is rounded. This is not exact because we've rounded. Almost 3 radians. Okay? Makes sense that half a circle is 180 degrees? Is 170 degrees almost 180 degrees? Yeah. Does it make sense that half of a circle is pi radians? 3 radians is close to 3.14, so a little bit less. So we can start to see how we can think in radians as opposed to thinking in degrees. Okay? Next one, negative 12 pi over 11. We're going to start thinking in radians. First of all, in standard position. Yes, Sam? Yeah. In standard position, remember that negative angles went in a clockwise direction. Positive angles counterclockwise. Same thing with radians. This is going in a counterclockwise direction. Okay? If we wanted to change 2 degrees, because right now, most of you probably like, what quadrant is this in? And you look at it and go, I have no idea because my brain can't think about radians yet because I haven't practiced that. But if we change this to degrees, might you have a better idea what quadrant it's in? Okay? So, negative 12 pi on 11, what are we going to multiply by? we want our answer to be in degrees. This is in radians. So I'm going to write the word radians here. And then I'm going to multiply by, and I'll put radians on the bottom here and 180 degrees on the top, because I want the radians to go away and be left with degrees. Again, I'm multiplying by 1. So what this does is it only changes what type of unit I'm using. It doesn't change the value. Now, when you multiply this, can you see that the pi's would cancel out as well? Very nicely. And so we have 12 times 180 divided by 11. I go to my calculator. 12 times 180 divided by 11. And I get negative 196.4 degrees. That's probably easier for you to draw. Can you see that's just a bit more than 180? If I was drawing this in the negative direction, I would go a bit more than 180 degrees. You can probably visualize this as negative 196.4 degrees. But I'm going to want you to be able to visualize this directly in radians. How would you do that? Well, first of all, some important things you need to know. You need to know that all the way around a circle is 2 pi. Halfway around a circle is pi. I need you to be able to see the fraction of negative 12 over 11 as negative 1 and 1/11th, as a mixed fraction. So negative 12 pi over 11 is the same as negative 1 and 1/11th pi. Well, how far is negative 1 pi? Does that make sense? That would be negative 1 pi, halfway around. Because 1 pi is halfway around in the positive direction, negative pi would be halfway around in the negative direction. Then, the 1/11th is a fraction. You have to imagine, since pi is halfway around, imagine this split up into 11 sections. I didn't count. I did 11 perfectly. They're not drawn perfectly, but I'm pretty happy that there's 11. And you would have to go 1/11th more, which would end there. Did you know, there is one, speaking of circles and 11, there is something that looks like a circle that has 11 sides. So like an octagon looks like a circle but has 8 sides. The most common octagon that you see in your life is a stop sign. Perfect. What is the most common 11-sided shape you see in your life? Does anyone know? A loonie has 11 sides. That's weird, eh? Yeah. He's like, I thought it was round. Check it out. It's got flat sides. And there's 11 of them. That's crazy. All right. If everybody brings me a loonie tomorrow, I can show you. Okay. So, did we answer everything in part B? Sketch the angle in standard position. We did that here in green. Determine its measure to the nearest tenth of a degree. We did that as well. We did that part first because we thought it would help us draw it, but now I've shown you that you can draw it just thinking in radians. Again, that's what we're going to want to do. We're going to want to be able to think only in radians or only in degrees and not have to switch back and forth over and over again. Okay? Shortcut for changing radians to degrees if there's a pi. So if I told you, how many degrees is pi over 6 radians? Shortcut would be 180 degrees divided by 6, 30 degrees. Okay? That only works if there's a pi as a shortcut. When we get to part C says the angle is 7.5 radians. If you want to change that to degrees, is that what it asks? Determine its measure to the nearest tenth of a degree. Okay? So I have radians. If I want to multiply by something, to get rid of the radians, I'd want radians on the bottom so that they cancel out. So that will put pi radians is equal to 180 degrees. Take out my calculator, 7.5 times 180 divided by pi to the nearest tenth, 429.7 degrees. I can't use the shortcut in this one because there's no pi in the original to change it. One other little thing about angles. You know when you have degrees, you have a little symbol to show degrees. Right now, I've been writing radians every single time. Is there a symbol for radians? You would think R, something like that. There's actually no symbol for radians. So do we have to write radians every single time? No. You don't have to make one. In fact, the way that you write radians is you just write the number and you don't have anything. So it means every time in grade 10 that you wrote an angle and just wrote 30, you technically wrote 30 radians. Which 30 degrees is like this, right? I'll hop and demonstrate 30 degrees. All right. That was very good. 30 radians. I will not hop and demonstrate 30 radians, but once around would be 6.28 radians, 2 pi. 30 would be almost spinning 5 times in a row. Okay? I think I might succeed if I started on the top of the school. And just start spinning until I hit the ground. Yeah. Here. Okay? We can pretend on the video since people can't actually see me. I'm walking outside the classroom right now, climbing up to the top of the school. Okay, and now I'm going to, it's windy up here. Now I'm going to, so it's windy up here. Okay. I'm about to jump and spin 5 times. Here I go. All right, your questions to try are 4, 5, and 7.